Stoichiometry is a keystone to chemistry. It's relating amounts of chemicals to each other using a balanced chemical equation. This must be done on a mole-to-mole basis. Here's our balanced chemical equation. Remember that if there is no coefficient in front of a chemical, its coefficient is understood to be 1. In this first problem, we're asked to relate amounts of sulfuric acid to amounts of aluminum oxide. So we're actually going to use our balanced chemical equation to write two different conversion factors. Reacting 3 moles of sulfuric acid is the same as producing, or is equivalent to, producing 1 mole of aluminum sulfate. Or producing 1 mole of aluminum sulfate is equivalent to consuming 3 moles of sulfuric acid. So note we're using the coefficients from the balanced chemical equation to relate one chemical to another. This is our measured number that's given in the question statement. We want to cancel out units of moles of sulfuric acid, so this is the conversion factor that we're going to use. It tells us that consuming 3 moles of sulfuric acid is equivalent to producing a mole of aluminum sulfate. Writing out the identity of these compounds helps us understand why, in this case, we need to divide by 3 rather than multiply by 3. So we keep the coefficient and its chemical together. In this way, we see that our units of moles of sulfuric acid cancel out, and we end up with moles of aluminum sulfate. So we get our calculator answer. Now we worry about sig figs. 3 sig figs in this measured number. This number is exact. It does not impact sig figs. It doesn't affect sig figs at all. So we need to use 3 sig figs when expressing our answer. We round up and we get our final answer as 0.117 moles. The second problem, very similar. We're comparing aluminum oxide to sulfuric acid using the same balanced chemical equation. As always, we start with the measured number in the statement of the question. Again, we're going to use our balanced chemical equation as a conversion factor. In this case, we want aluminum oxide and its coefficient to be in the denominator so that we can cancel out units of moles of aluminum oxide. Note we keep moles of aluminum oxide with its coefficient together and moles of sulfuric acid with its coefficient of 3 together. This setup indicates that we multiply 1.5 by 3 to get our final answer. Here's our calculator answer. Let's look at sig figs. 3 sig figs here. This is exact, so it's not going to affect sig figs. We want to express this answer with 3 sig figs. That means that we're going to have to add a 0 to the end and express our answer as 4.50 moles. Simple stoichiometry problem. We're relating moles of oxygen to moles of nitrogen through this balanced chemical equation. We're going to get our conversion factor from the balanced chemical equation. We need moles of O2 to be in the denominator, so we want moles of O2 along with its coefficient to be in the denominator. In the numerator, we want moles of N2 along with its coefficient in the balanced chemical equation. Now we do the indicated math and we get our answer. We write down our calculator answer. We see we have 3 sig figs here. This is exact, so it's unlimited sig figs. We want 3 sig figs in our final answer. We round up, so our final answer is 0.307 moles N2. The next problem, we're relating N2O3 to oxygen. We again start with the measured number from the question statement, and we remind ourselves we want to end up with moles of N2O3. We need to cancel out moles of oxygen, so moles of oxygen along with its coefficient needs to be in the denominator. Write down our calculator answer. Now we can do sig figs. 3 sig figs are justified. And we have our final answer.